So starting off, we're going to talk about the top vulnerability, number one, injection. Injection attacks are some of the worst out there because they often lead to remote control execution. It stands for, the acronym RCE. It stands for remote code execution, but basically it allows you to execute anything you want to on the remote system. There's a reason that it's been listed on the OWASP top 10 since the original iteration in 2003. It's one of the most prevalent vulnerabilities, and web developers still can't really get it right. So it's still on the list. It's still number one. One of the main problems here is that injection can happen with almost any protocol on the internet. There's SQL injection, LDAP injection, XPath injection, NoSQL, OS shell injection, which is really bad. That's running commands locally on the server. Users should never ever be able to access a shell on a remote server unless it's in a very secure way, and it's hard to do. XML parsers, SMTP headers are all vulnerable to injection as well. So there's a lot out there. It's a huge attack surface. Part of the problem is that injection is possible wherever there's user-controlled input to anything, pretty much. That's why it's so prevalent. Normally, when you're building web apps, it's to interact with users. So obviously, there's a conflict here. So whenever you're taking input from users, you need to make sure that it's done in a safe way. So first, I'll show you an example of a SQL query here. This is written in Java, for example. It's just 2 lines. All it's doing is setting a query string variable, and this is with the intention of sending it to a SQL database server later to query for information. So all it's doing is saying select all of the, where's my laser pointer here? It's saying select star, which is just a wildcard for all of the columns in a table from the accounts table, where cust ID equals request.getParameter ID. And so this is just a method that gets input from the user. All it's doing is concatenating this user input into a SQL query here, which is really bad. And it's doing it without any checking or anything. It just throws it in there, no questions asked. A normal user would submit safe normal input. For example, I would input bblodget for my username usually. That would running in code cause my input to go in there into the customer ID value in your SQL query, basically. So then that gets ran against the database and returns my user account. Of course, there's extra code needed to do that, but this is just showing that when you enter a URL with this ID, it gets put here in the cust ID field of your SQL query. Now, a malicious attacker, for example, can submit input that looks really odd, but they can submit something like this, where it's just an apostrophe or '1 apostrophe equals '1. Now, that looks really strange, and you wouldn't think that that would actually result in anything bad, but or anything at all useful. But when that's put into your SQL query, it's concatenated in there, no questions asked. The query you end up with is looking at the accounts table where cust ID equals apostrophe apostrophe, which is an empty string. Of course, that's not going to match anything, but it also says or '1 apostrophe equals '1 apostrophe. So that's just saying return all records from the accounts table where cust ID equals nothing or 1 equals 1. And 1 equals 1 is always going to be true. Of course, 1 always equals 1. And so that's really bad. What this does is causes all records in that table to be returned to the attacker. Obviously, there's a lot of problems with that. So as another example, most web developers these days, because of its ease of rapid application development, use Node.js. Node.js is also vulnerable in some ways. So you still need to watch out for code injection. This is a specific example showing 3 lines of Node.js code. All it's doing is declaring a constant variable file name equals process.argv2. For those of you who don't know, in Linux command line, the process.argv2 is just going to be an argument you pass to a program through Linux command line. So you would run node space your file name.js space whatever file name you want to pass to the program, and that'll be put here in the argv2. And then const std out stands for standard out. That's another constant variable it's declaring to execute the cat command. If you don't know Linux, that just says, I believe it just stands for catenate. It just dumps the entire text of the file out to your prompt. So you use that to view a file or the contents of a file. So it's taking that argument and putting it straight into your command. So it's gonna dump out the contents of any file that the user puts in that argument. This seems really cool. It seems like it could be useful, but it can also be very, very dangerous if it's done insecurely like this. And then the console.log part of this is just printing out that output to the prompt. So if an attacker decides to run node myapp.js and then pass this command to it, this looks, again, just like the last slide, it looks pretty strange and you wouldn't expect that it would actually do anything useful, but it's really, really bad and malicious. The command that gets executed because this input goes into that variable and it's unchecked and it gets concatenated onto the end of the cat command, it ends up running this on the server, on the web server. So it cats the file.txt, so it'll print the full file, but then the semicolon tells it to end that command and run the next command immediately after it. So this next command it runs is rm-rf space /. What that does in Linux is removes and recursively removes files, and then the F tells it to force remove them, so it closes them if they're open, if it can't access them, and the rm command tells it to delete those files. The / tells it the root of your entire file system. So this command essentially deletes everything on the server. So obviously that's super, super bad. You never want that to happen. That's why you always need to validate user input. In this case, the attacker would be able to run anything they want to on the server. Talking about the impacts of injection, malicious attackers would be able to access, manipulate, add, or delete any data they want to. So that kind of opens you up to all different sorts of attacks. This is a really bad entry point for attackers. Attackers can also use tools like SQL map to exfiltrate the entire database. SQL map is just, if you Google it, it's available on GitHub. It's an open source tool that was created for security testing, but it's also used very maliciously by attackers to discover these SQL injection vulnerabilities in your app and exploit them in a way that it programmatically maps out your entire database, and can even be used to gain a root shell on your web server. So it can be really bad. This is an example of SQL map in action. This is the command line window shown in Kali Linux. You can tell by the logo in the background. But basically what you're seeing here in this result is a full database table. And it shows some sensitive information such as user first name, last name, and passwords. Even if those passwords are encrypted there in the database, if you get a hold of this table and have those password hashes, you can easily crack those offline at your leisure. It just takes time. That's it. So for an example from the real world, we're going to talk about the Illinois voter registration database leak that happened in 2016. It was, I believe, it was done by Russian state-backed hackers. 76,000 voter records were stolen, including names, addresses, dates of birth, driver's license numbers, and partial social security numbers. The technique to exfiltrate that data was SQL injection, and it was going on for a very long time before anybody even noticed this. It was detected due to the noticeable impact on the database performance and frequent queries. So only after some users started complaining enough to their IT department that their database was slow, or it was being slow to run reports, or was just timing out for them, they complained enough to their IT department that they actually looked at the monitoring and saw, oh, hey, there's tons and tons of queries going to this database, and these look really strange. Where are these coming from? And they finally found out that they had been breached, and somebody was exploiting SQL injection to exfiltrate data slowly over time, just as fast as the database could put it out. Manipulating data in this breach was not the goal. And that's one of the reasons why it was, why Russian state-backed hackers were a prime suspect. Other state-backed hacker groups typically try to breach this kind of information in another country with other goals in mind, like identity theft or misinformation and impersonating users in that other country. So we still don't know the full impact of this, and this happened 4 years ago. We don't know if this could come back to bite us later. It probably will, and we'll see more news about it like we usually do. So now talking about prevention of injection attacks. There's certain best practices that you can follow to reduce your chances of introducing an injection vulnerability. And there's a lot of information out there and other resources I'm going to give you links to as well that talk about how to prevent injection and all sorts of different protocols. So the first golden rule is never build SQL queries by string concatenation. As we saw earlier, that's a really bad idea. You want to use parameterized SQL queries. And what parameterized SQL queries are queries where the escaping and untrusted user input is basically validated and escaped for you. So it makes it a lot safer. It doesn't prevent 100% of injection attacks. There are still ways that you can you could be vulnerable, and a hacker could use that to leak your entire database still, but you're going to avoid the majority of those possibilities if you use parameterized queries. So what I mean here is, here's an example of vulnerable code. I believe this is JavaScript, but you get the idea. So the vulnerable code is just setting a constant variable here that says select all users from the users table where username equals whatever the user input, and that's concatenating. That's bad. The safe way to do it, or the parameterized query way, is to define the query string put a question mark wherever you have user input variables or user input at all. And in your next line of code, you declare another constant called results, say db.all, put query for the first parameter and username for the second. The query is your full query string here, so it just tells it. Basically, it looks at that, it sees the question marks, it knows that there's going to be user input in those places. So the first question mark in your query you would put as the first argument following the query to this method. Sorry if that's a little confusing, but the idea here is that if you had like 3 question marks, like you have 3 user input fields here in your query, you would have additional arguments here in your db.all when you call db.all. So you would have another comma after username and then the next variable and comma and then another variable. And those just get plugged into those question mark spots in your query. And when you do it this way, there's protections in JavaScript in this db.all method that do the escaping for you. So there's a lot less to worry about. Another solution is to use object relational mappers. And that one I'm not going to dive too much into. Basically, ORMs are just modules and libraries of third-party code that handles escaping and untrusted user input for you. So it makes it a lot safer. And there's plenty of them out there. It depends on what language you're using and what you're using it for. So there will be more information I'll provide links to for object relational mappers and parameterized queries because there's a lot more information out there. For preventing the second type of injection that we talked about, command injection, just like with SQL injection, never build these queries or these commands with string concatenation. Use parameterization. This can also be done with commands, not just SQL. Parameterization is it's a solution to a lot of types of injection. Input validation. You always want to validate user input. Even if you're using parameterization, in some cases, you'll probably still have to do some kind of input validation because there's always going to be new ways that hackers come up with to bypass current protections against injection, basically. You want to use an allow list rather than a deny list. Kind of on a tangent here, there's a shift in the industry currently from using the terms whitelisting and blacklisting to allow list and deny list. And that's simply to stop associating color with good and bad. For obvious reasons in our current day and age, this is a shift that has been a long time coming. So use allow list over deny list, because in a deny list, you're going to have to come up with every single method that an attacker has of exploiting an injection vulnerability. And there's always going to be new methods that they come up with, unexpected ways, or something you just aren't thinking of. So it's a lot safer to specify input that's allowed than to specify all the many, many types of inputs that you wouldn't want to allow, if that makes sense. It's just much simpler. For further reading on this topic, see the OWASP injection prevention cheat sheet. OWASP has a lot of cheat sheets, and they're really, really good. But the injection one particularly is really long because there's a lot of different attack vectors, as I said. There's also a specific SQL injection cheat sheet, and then there's also an input validation cheat sheet.